Hello everyone, my name is Ryan coming to you from the DL Academy, and in this video we're going to be making a web scraper that goes on a car selling website, retrieve the information from the website and fetch it into a machine learning model to learn on it and predict car prices. Alright, so without further ado, let's jump right into it.
Hello everyone, my name is Ryan coming to you from the DL Academy, and in today's video we're going to make a Python script that predicts car prices retrieved from the internet. So we're going to be building a machine learning model that gives us a predicted price, and we will compare it to the actual price, and this therefore the program will tell us if we're making a good deal or we're making a bad deal. Um, so for this tutorial, you'll need to know a little bit about web scraping. If you don't know anything about it, we actually have a tutorial on our YouTube channel. Here it's Instagram bot. This is actually a web scraping tutorial. You could watch that. And if you don't know machine learning, you could go on our website, thedlacademy.com, and then go on explore the basics of machine learning and AI. Here you find a course that will teach you machine learning and a bit of artificial intelligence. All right, so now that we have this out of the way, we can get started with our Python program. Now, the website that we're going to be using is called Kijiji Auto. So go on Google and type in Kijiji Auto and click on the first website that pops up. All right, here. And let's say we're looking for a sedan type car. So the moment I click on it, you will notice that here the URL has changed. It redirected us into the cars directory and then sedan. And here we have a bunch of cars, and we can scroll down. And what I notice is when I scroll to the bottom of the page, there's actually more cars that load. So anytime I scroll to the bottom, there are more cars that are loading. So let's remember this fact, and let's just take a look at the HTML by right-clicking and then clicking on Inspect HTML. And let's do it again because no, actually, let's look at this. This is an li element. This is not what we're looking for. These are a bunch of div elements, and okay, this is the big div elements, and this is the unordered list that contains a bunch of div elements. All right, so this is already interesting. Now we can look at one of them. This is, let's say, the first one. It's a li, and then we have, let's try and look for the href. Here's the href. We found it, and let's just click on it, and it opened up the page corresponding to the car, and we notice that the same href is just added to the base URL. All right, now let's scroll down a little bit and take a look at this overview. So this is what we're going to be using to create our model. Basically the make, the model, the year, and I would have liked to have seats, but it seems that it doesn't have the number of seats. So, all right, so these would be our features. So we already have 3 features, and then our label will simply be the price. So this way we could then, for example, input any type of makes, and it will give us a price. And if the price indicated on this website is greater than the price predicted by our model, we're having a bad deal. And if it's lower, then it's a good deal. All right, so we have all the information we need to start coding our program. Let's go and open PyCharm. Let's open PyCharm. And I haven't coded this. I'm actually making it spontaneous on the go. So I'm not sure how this is gonna unfold, but let's just hope for the best. All right, so let's not load any previous project and create our own project, and we will call it. Well, it has to load first. All right, so we will call it Python car predict, and we have to make sure that we inherit global site packages and create our program. Now let's close this pop-up right here, and let's create our main Python script. All right, here we go. And let's just wait for the process to complete. All right, so let's create two new Python files by coming here and doing the exact same thing. Right click, new Python file, and let's create, let's name one scrapper. All right, so this will retrieve the data from the website and create another file, call it create model. So this one will create model. So of course these are classes. So class create model, and let's define the init function. Init like this, taking at least a self parameter. And for now we'll just do, for example, pass. All right, so this is our create model, and here it's our scrapper class. So scrapper like this, define init with a self and pass. All right, this is the main. So let's come back to the main file, and let's create a main function. Well, let's start by importing scrapper and importing create model, and let's define a main function, and here pass again, and then say if underscore underscore name underscore underscore equals underscore underscore main underscore underscore. I think that's how you do it. You have to run the main function. And here, just to make sure that it works, let's print running script. All right, so just some basics. Of course, if you don't know Python, we also have a Python course, and as you can see, it worked. The Python course, which you can also find on our website. Now let's go on our scrapper, and here is where all the magic happens. So let's start by importing Selenium, because that's what we're going to be using. Selenium. If you don't have it, open your command prompt cmd and type in pip install Selenium like this, and this should install it for you. But I already have it installed, so it shouldn't do anything, as it says requirement already satisfied. And we're also going to be using Beautifulsoup. So import from Beautiful. This one I don't think I have, so let's make sure I download it. Pip install, and it's, if I remember, Beautifulsoup 4, if I remember correctly. And this, okay, I do have it. So what's the problem? So from BS4 import Beautifulsoup. All right, Beautifulsoup. Okay, so that, let's say as BS. So this just imports Selenium and Beautifulsoup for us. And all right, so let's create a first variable and call it self.driver, and we're gonna make it equal to Selenium dot. Okay, so here we have to say from Selenium import driver, WebDriver, and then here we're gonna be saying self.driver equals WebDriver dot. All right, so here we're gonna be saying WebDriver dot Chrome, and here we should input the path for our Chrome WebDriver. All right, so here I'm not sure where I saved mine or if I even have it. Um, well, if you don't have it, you can always come here and type in Chrome driver and then download. And then the first link will redirect you to the page where you can download the Chrome driver. And here, since I'm using this version of Chrome, I'll just get the Windows 32 zip version, and this should take a couple seconds to download. Hold on, let me go check it on downloads here. Okay, and I can just open it like this, and here is the Chrome driver.exe. We can extract it. I'll extract it to documents, and then go here, and then on documents, try and find my Chrome driver. Let's just copy here. Let's find the path where so I go on documents here, and I should find it somewhere here. Where is my Chrome driver? Here's my Chrome driver. So I'll copy the path here, and I will paste it in inside the parentheses. No, inside the quotation, and Chrome driver dot exe. All right. So this should do it. I can put here R so that it says, so it inputs it as a raw string. But now we have our Chrome driver, and we can say, for example, we can create a variable called self.url and make it equal to https www.kijiji.auto.ca, and this is our URL. And then we could just do self.driver dot, well, we have a mistake here. All right, dot get, and here we'll do self dot URL. And then here on main, all we have to do is create our scrapper object. So sc equals scrapper dot scrapper, and this should run everything for us. Let's run it and see what happens. All right, so it says type module object is not callable. All right, so I found the mistake, and here it should be a capital C, and this should fix our error. Let's run the program now, and now it seems to be working. So let's allow access, and we get an error. So what does it say here? It says session not created. This version of Chrome driver only supports Chrome version 83. So I might have downloaded the wrong version of our Chrome driver. All right, so I downloaded a previous version of Chrome driver, I think version 81, and now it's working. So when I run the program, it actually opens a new Chrome tab, and it should load what is it called, the Kijiji auto URL. All right, so let's remove this because it doesn't seem to be working. Let's create a new function and call it load URL, and here we'll just do self.driver.get self.url, and then here on main we'll just do sc.load URL. Let's also here import time, because it's going to be very useful for our web scraper. Time.sleep, so we can pause. Here we could implement it. We can say time.sleep and sleep for 1 second before retrieving the URL. All right, so I did find a solution to the problem, and the reason why it wasn't loading is because I typed in HTTPS. By removing the S, this fixed the issue, and now the page is loading properly without any issue. So as you can see, now it actually loads the page. So maybe just because of the way SSL or whatever the encryption works. We just have to remove the S and it's gonna work. All right, so now we can keep moving and keep coding and get back to our program. All right, so now that we loaded a URL, let's actually not load it here. Let's load it into cars/sedan. So let's just add a string to it and see if it brings us to the correct category. So okay, it didn't work. Maybe cars with an S, maybe? I don't know, I'm not really sure. Here, cars with an S, yeah. So just add an S here and it should load us into our cars. So, okay, all right, here it is. And it seems to have been working properly. Now, what we want to do is scroll down a bunch of times. And of course, the page closed because we put a 3-second timer. But what we want to do is, okay, all right, for now, let's add like 3,000 so that it doesn't close on us. But we'll take it off later on. And yeah, let's run this because we need to inspect some HTML. Let's go here and create a new function, call it scroll down. So here to scroll down, what we simply have to do is say self.driver.execute script. So execute script, and here let's pass in some JavaScript. Window. Hold on, I have it here. Dot scroll to, and then in parentheses, simply put a 0 comma document dot body dot scroll height. Now let's try and run this and hope that it works. Perfect. So as you can see, it did scroll to the bottom, but it only did it once. This is because we only told it to do it once, since we execute the command only one time. But this is what we wanted. So it did scroll to the bottom of the page, and we want to scroll and keep scrolling even more. So for that, let's simply create a for loop. So for underscore, because we don't really care about the variable, and then the range is simply going to be let's do it, let's say 100 times. All right, and so 100 times, all we want to do is scroll to the bottom of the page, and this way this will load all the HTML that we need onto the page so that we can retrieve it after and save it for our model to train on. Now let's just see if it's working. So it's waiting 1 second and then does it again, waits 1 second and then does it again, and then it keeps on scrolling to the bottom of the page. We're going to be doing it 100 times when we're actually going to be testing or training our model, but for now let's just make it like 3 times or something. So scroll range, let's make it equal to 3. We'll change it to 100 after, but for now let's we don't have all this time to waste. All right, so once we scroll everything, our goal is then to retrieve the HTML, and for that we're going to be using Beautifulsoup. So let's create a function, call it read data, and here okay, all right, so let's go back here and try and find the div element that contains everything, and it seems to be this one right here under this class. Let's just copy its selector and then say main equals, and then here we're simply going to be saying self.driver dot find element by CSS selector, and then paste it in here. And after after we're done with that, let's create our soup object. Soup equals bs of main dot get attribute, and then here we're gonna access the inner HTML without underscores, so just inner HTML. So this is the first parameter, and the second parameter is simply gonna be HTML dot parser. So here we can then print our soup object, and then soup dot maybe text, so then we can access the text. Let's go back here, and after we're done scrolling, let's just say sc dot read data. Now let's simply run the program and see if it gets the HTML. All right, so it only printed filters reset, which is not what we want. It seems to have seems like it didn't work properly. So let's just inspect here. So since the CSS selector doesn't seem to have worked, let's copy the XPath and then go back here and find by XPath, and then change the whole string here. So let's change the string, and hopefully this works a little bit better. Now let's run it and take a look at the results. All right, so it did print something, but it doesn't seem like it's the HTML. So maybe it's the fact that okay, it's because the error comes from the fact that we're only looking at the text and not the whole HTML. But if we were, we should be able to get the HTML of the page since it printed the text. So this seems to be working fine. And now all we have to do is retrieve all of the links and save them into a list. This way we can access them individually and look at stuff such as the model, the make, and the year. And as you can see, it seems to have worked. All right, so it did load this one, Chevrolet Cruze, but this is part of the first load. So what we should do here is add a time dot sleep a couple seconds. So let's say 5 seconds before retrieving data, because it didn't have time to load all the data before we read the data. So we read the data before it was loaded. So by adding a time dot sleep, this should ensure that all the data is loaded before we try and read it. Now let's try it one last time and hope that all the data loads before we read it. All right, so it printed everything. Now let's look, for example, at this one, 1964 Jaguar. Control F, 1964, and it seems like we have it. 1964 Jaguar. Yeah, here it is. So this is working perfectly. Now all we have to do now is loop through all of them and try and find what is it called, the links. So let's right click and inspect the element once again like this, and we're looking for so this is what we're looking for. So all the elements that contain this class, so we can access their href. So let's copy this here and go back to our read data, and we're going to be saying for every element in soup dot find all like this, and then we're looking for, hold on, a element, so a tag, the a tag, and then here all the a tag that have a class of this. All right, and then here all we can do is simply print elements and then get the href. So this should print all of the hrefs for us. Let's try and see how it is. And we have an error. It says invalid syntax. Why? Okay, we forgot a column. And let's just run this again. All right, so this didn't work. So I'm pretty sure now we have to do lm.href. Just print the element for now just to see what it's like. Maybe this is going to help us a little bit. All right, so we have the a tag. And hold on. All right, so I finally figured out a way to get the href, and it's because I noticed that when I go here and inspect the element, let's do it again because site is annoying. But here I noticed that it says -vap / and then a number. And then I noticed down there that the number is actually the data test add ID, and that it's the same number. So if we're able to retrieve that number, because it doesn't let us retrieve the href, but if we retrieve the number, then we have a way to get the href. All right. All right, so here in our for loop, all we have to do, well, for now, is print elements dot div, and then here simply get what is it called? Data test add ID. So data dash test dash add ID. All right, so let's run this. Perfect. So now we have a bunch of IDs, and this is exactly what we wanted. So now we can come here and create a new variable, say self dot hrefs equals, and let's initialize it to an empty list, and then here simply say self dot hrefs dot append, and we're simply gonna append well, first it's gonna be VIP / and then here we're just gonna be adding the ID, so dot format, and then paste this, which gets us the ID and convert it into a string by typing str. Perfect. So now what we can do is well, we can create a function, call it get hrefs, and this will simply return self dot hrefs, and this way we can come here, and after we read the data, we can simply print sc dot hrefs. No, get hrefs. All right. So let's remove the print statement because it is useless. Now we'll simply print it in the form of a list. All right, so let's run this. All right, so it seems to have worked. Now let's copy one of them and go on the base URL and simply paste it and see if it redirects us to the page of the core. All right, so it did work, and here it opened up the page for us, and this is the page of the core. So now what we can do is simply come here and retrieve all of the information that we need, and for that we'll create a function. So we'll call it a function called define get info, and for that we will need to select this part of the website. So let's just right click on it. Which part was it? It's core features, so it's this. Inspect, and it brings us here, and then here we need this part, like this, and we need to access the li elements. All right, so let's just copy copy this copy. Let's copy the XPath and come here and say driver, no, self dot driver dot get, and then here we will need a URL. So let's add another parameter and call it URL. So we'll get the URL, and after that we will simply say we'll import time. So import time, and we'll say time dot sleep for 1 second, and then we will say description or features. It's called core features. So cf equals self dot driver dot find element by xpath, and simply paste the xpath, and then we need to convert it into a soup object. So soup equals bs of cf dot get attribute of inner html, just like we did before. And then here outside it's simply an html.parser. There we go, we have our soup objects, and then we can loop through the li elements. So for every li element in soup dot find all, and then here it's li, and then it's simply gonna be we need this one. So let's print li dot text. Hopefully this works. We'll try it on this one. All right, so after we print the hrefs, what we could do is run sc dot get info of http gg auto dot ca slash plus this. So we'll try and run it on this URL and see if it works. Let's just go here and say from selenium dot webdriver dot common dot by import ec, no, import by from selenium dot webdriver dot support dot ui import webdriver wait, and from selenium dot webdriver dot support import ec. Import expected conditions as EC. All right, so once we have all of this, we can come back down here and say here, so CF equals, let's remove all of this and say WebDriver wait. So self dot driver dot until ec dot presence of elements located, and then here double parentheses by dot xpath comma, and then here simply paste in the xpath which we need to get because I didn't save it. Hold on. let's go here, and it was simply the XPath for the description, no, core features, and it was this, I believe, this. All right, so it's this for the unordered list. Copy XPath. Let's go here and paste it, and then save and run. Oh yeah, the timeout is required, and the timeout here is after the driver, so comma, let's say 100 seconds. So if it doesn't load, well, we should decrease it, but my internet is pretty trash right now. We'll just keep it at that. Ideally, you'd have it lower so that if it doesn't load, you just skip that. So it's in the try and accept statement. Oh, it's Kijiji Autos with an S. Kijiji Autos. I think that's where all the problems are coming from. Okay, yeah, exactly. It's the S that I was missing. Now it should work. Alright, so simplest thing now to do would be to just here, let's copy the selector. Alright, so let's try using selector here instead of XPath. So CSS selector, comma, and let's remove all of this. And paste in the selector here. Yep. All right, so it did print it in the end. And so we have a make, a model, a year. Sorry, so we have a make, a model, and a year. And this is what we want. All right, so perfect. Now this is working. What we can do now is save it into our features list, a list of features. And all right, so here what we're going to be saying is if make in, okay, all right, so let's say, for example, the text in our variable in a text, so our text in a txt variable. Let's save our text in a variable, and it was li.text. So if make in text, what we can, or here it's txt, what we can do is print text txt dot, hold on, txt is a string, so we should be able to do str of txt dot strip, so it removes makes and space. All right, and then we'll say else if model in txt. We'll do the same thing, but we'll remove model, and I'll explain this while I'm done. Here, let's remove model, colon, and space, and finally, let's add a last one. If year in text, we'll simply remove year, and let's run this. I'll explain it once it works. All right, so here I think it almost worked properly. Here it should be key. I don't know why it says key. Year worked. Let's print the text also. All right, so to fix the issue that we were having, we would simply take the string and then start from the fifth element and all the way to the end. And then here for this one, we'll start from the sixth index and go all the way to the end. And this one, and then after, of course, we'll call the strip function to get rid of the spacings, dot strip, and same thing for the last one. All right, so this should return results like this. So it should so give us the year 2016, a model, a Ford. So here it returned Ford, and a make, which is Kia. Here it returned Kia. And the reason why we're doing this is because here if we start at index 0, it's this. It's the M. 1, 2, 3, 4, 5. We would actually start. It would return only what's after the fifth index. So that's why we put a 5 and a colon, which means everything else after. And then here 6 because model is one extra letter. And here for year we don't need to do it because when we call the string function and remove all of these letters, here the 2016 will always stay because 2016 are numbers. So even though we call the strip function, we could have done the same thing, but removing letters also works because these are numbers. All right, so now that we have all of this, let's actually save them somewhere so we can access them later on when we want to create our model. So let's create self.features equals an empty list. And then here all we have to do is save these into a variable. So make MA equals this. So make will be equal to that. We can also print it. It doesn't really matter. But let's not do it here. Model, so MO equals that. And then here, finally, year. So YR equals this. And then here, MO, YR. Okay, I'm just checking if I have access to these variables here, YR. And all we have to do is say self.features.append, and then we'll append a list of MA, MO, YR. And that's what it's going to do. It's just going to append this. And this, I think we should take it outside the for loop. All right, so all right, so here let's also create a new function and call it get features return or get features. And what this does is it should run get. Here let's pass in a URL, and then we're simply going to run self.get info with the URL, and then return self.features. And here now what we need to do here, instead of running get info, we'll simply run get features and do the same thing, pass in the same link. But this time it's going to return the features so we can print all of this. Let's run this. We should get a list containing Ford, the model, the make, and the year. All right, so it did work. It did add this, so a list containing the model, the make, and the year. So this is perfect. Let's just so what we can do now, let's remove this comment here, and So now we have the hrefs. Once we have the hrefs, we can loop through the hrefs. So for h in sc.get hrefs, we can do sc.get features sc.get features with this, so the base URL plus the h, so which is the hrefs. And now here let's create a features list, make it equal to an empty list, and all we have to do is say features. Did I append it before? I did. So we don't need to recreate the features again. All we can do now is we could simply print it. So print sc.get features. So this should just print the list at every step, and the list should increase until the very end. Let's add a quick time.sleep of 10 seconds here before we start scrolling. But oh, it did work. And all right, so this is our first. So we added this, and as you can see, the list is increasing. So it's adding these lists into our big lists. So we have a model, a make, always, and a year. And this should do it for all of them. We got an error. Further information, do not hesitate to contact us. Hello everyone. So let's continue from where we left off last time. And we were stuck at a problem because somehow the website was able to detect our web scrapper, and it would block us after, if I remember correctly, about 3 requests, it would block us, and we wouldn't be able to continue. So I did some research and came up across this website, and it's called Proxy. What is it called? Rotate proxies and IP address. So I figured that the reason that the website was able to block us is because it knew the IP address from which the request was coming from, and if it saw the same address multiple times, it would block the scrapper. So what I did was came down here and took this bit of code, which basically goes to this website right here, which generates a list of proxies. As you can see, we have a list of IP address and ports. And what the code does is it takes these IP addresses and then returns a list of them. So basically, it plays with the HTML, takes the HTML and returns a list of these proxies, saves it into a dictionary, and then loops through them. And here, basically, it sends the request. It uses the next function. So each time we use the next proxy in the list, and then here it inputs it as a parameter for HTTP and HTTPS. All right, so I took it here and basically copied the same code. I added a bunch of ifs, print statements. Here, if I remember, they were taking the first 10 elements. I took this off so that I would get the full list. That's the first modification that I did. The second modification that I did here was instead, here they looped for the first 11 elements. I'm looping through the length of all the proxies. And I believe here, for example, it returned 125. So that's enough for us. And what's good about this method is that the get proxies is a dynamic function. So basically, we can use it again. And here the proxies are always updated in their website. So if we keep getting an error, we just have to wait and they will update their proxies and we will have new proxies. All right, so that's what I did. The rest is exactly the same as the code here on this website. I will link it in the description if it's requested. And I added a break statement here. All right, so this is just what we're going to be using in order to break through that error. So let's open, what did I call it? Python core predict in a new window. Now let's let it load. And where were we getting the error? I think it was in get info, right? Yes. The make, the model, find out li. All right. So basically, all we need is a way to get the HTML. Right? So let's copy this. Let's copy the imports. Let's copy the imports on top. Okay. Let's copy the functions. So we have get proxies. This is the first function that we're going to be needing. Let's paste it here. Get proxies takes a self parameter. Make sure to put that in. And the other function is, okay, this is not a function. This is we copy this bit of code here, and we're gonna put it in our get info function. All right, and then here we will take this response and a variable. I'm not sure if I can access it here. I hope I can, because response.text is our HTML. So here HTML will simply be equal to response.text, and the rest should be exactly the same. So here I just remove this bit of code, and this should do it. All right. So it's basically gonna, here I have to put self.get_proxy, so we access the function that we created here. And then hold on, here we're printing the response.text, skipping connection error, and then here make, I think that's pretty much it. Hold on, to get all our data, print the get features VIP. I don't really remember, it's been 2 weeks. Hold on. All right, so I noticed something here, we're getting import error. So let's open our command prompt by typing it cmd on the search bar, and then type in pip install, and we need what was it called, lxml. Oh, hold on, like this. And we're also going to be needing requests like this. And after that, everything should work just fine. It's uploading for its indexing, so that it gives so that it imports the new libraries, the new modules, and it has them here. Perfect. Now hold on. All right, let's do some quick modification to this code here. Instead of appending all of this, what I would prefer to do is just return a list containing the make, the model, and the year, like this. This looks good for me. And then here, what is it? Get features. Let's get rid of this. All right. Hold on. Load URL. I think I made a mistake somewhere. No, I have to delete everything. Now we go back to the main file, and here it says get features. All right. So remove this, and we'll create a features list. Features. It's an empty list, and all we have to do now is say features.append sc.getFeatures. get info, and for the URL is going to be the base URL plus h. There we go. We can remove this, and at the end of the for loop, all we have to do is print features. So we'll print the entire list, and this is gonna do 3 scrolls. Let's only do 2, and here we can print the list if we want to, just to make sure that we have the correct information. And let's remove all of these print statements so that we are not overwhelmed. And then here we can just print got response. So alright, I think this is it. Let's try and run this. Let me move it here so that I can take a look at the code or the output. So alright, we have 104 proxies, and as you can see, they're already changed from the ones we were seeing before. We got a response. I think I did got a response somewhere. Where is it? I think I shouldn't have printed that much. Got response, and then here we have, alright, we have Civic 2015, but we have an error for the make/model. So this is not good. Unfortunately, there is an error. Let's see if the error repeats itself. Then if it does, well, let's stop this, and in scrapper.py, in get proxies, let's not print the proxy every time here, so that we don't have to be confused by all of this nonsense. Let's run it again. Alright, so I realized a mistake that we did, and here I said URL equals, and I fixed it to a particular URL, so it kept doing and working all these proxies on the same URL. So let's just remove this bit of code right here, and then it's going to use the URL that we pass in the parameter to get here instead of the one that we added afterwards. So that's it. Just do that and run it again, and then it should work perfectly. It's going to take a bit of time to retrieve all the data. On average, for me, it takes like 10 seconds, 15 seconds until it finds a good proxy. So let's say you'll have to let this program run for a couple of hours before you get a big data set, and then you could use it to train the model, which I'm going to show you how to create in an instant. But for now, we're just working on the web scraping part. We have to make sure that this works fine before we can move on to the next parts. And here I think there's another mistake where it didn't get the I think the model properly, or the make properly. So in this case, maybe we'll have to figure out a way around that, but I'm not sure. So let's just try it and see if the error persists. Alright, so one just quick little note is I was getting errors until I added an S here, so HTTPS, and then it started working properly. But we still seem to have the same error here where it says make/model. Here it gives us the correct answer, and here as well, but here it doesn't. So we'll have to figure out a way around this. Let's just print the text to see what we're working with and run it again. Alright, so I think I figured it out. The way we could fix the issue here would be to simply put a column. So if you find make column, because here I notice it's make column and you don't find that anywhere else. So if you try and say control find, it's only you only find it one time here, and this is the one that we are looking for. So just put a column here and here again, and then this should work for us. All right, so since this seems to be working and we are getting our features, so this is a list of features. We also need to remember that we need labels. So here we're looping through all the li elements to get the features, but we need to do the same thing for the labels. So here what I'm gonna do is say label is going to be equal to soup dot find all, and then here if we take a look at the web page, we're looking for this right here. So it's a span element, span, and here we're looking for a class, and that class is, hold on, let me just copy the class name here. There we go. And hold on, what happened? All right, we'll take the 0th element and we'll get the text. So we can now return, well, we can print that. We can also print the label, and here we'll return the list and add a comma and return the label. This way, features dot append, here we'll have to split it, x comma y equals, we'll copy this, the whole function, and then here features.append x, and we'll have to add a labels equals empty list, and we'll just say labels dot append y. Now let's run this and see how it does. I'm not sure if we should add the dot text here or if this is enough. I think we should, because the thing is under it. Well, we'll see. All right, so I just thought of something. In the case where none of the proxies work, we're gonna have an error here because HTML is gonna be equal to null, basically. So let's take account of that. So what we can say is add a try and accept statement. So try this, and then if we accept, all we have to do is return 0, 0. And then let's go back here to the main function and say if x is not equal to 0 and y is not equal to 0. So if both of them aren't equal to 0, then we append features and lists. Otherwise, we don't do anything. We just move on to the next URL. All right, so here it seems to have worked after how many attempts? 13, 14, 15 attempts, all right? So this is just to say that these proxies aren't really the best solution, but they definitely work. And for this program, it's definitely a good thing because it changes every time. So as you can see, this one took 15 attempts. This one only took like 1. So the first attempt already got it. And as you can see, we're returning a list of features and a label which contains the $sign, but I mean, it's not really a big deal. We can get rid of it by I think the way we could do it is simply saying label and then here 1 colon, label one column. I think this would get rid of the $sign. Let's try it. Let's see if it works. Let's remove the previous one. What's wrong with this? There we go. They tried to stop us, but they couldn't. We're too smart for them. All right, so since it's a bit slow, I'm not going to be retrieving a lot of features. I'm thinking maybe 1,000 and let it run on my main desktop for a couple hours, maybe a couple days, maybe 1,200 features, and then use them and run them on our model. Now, okay, so it did work. By taking the first element and a column means all the way to the end. So if I did so what this does basically is that like it says start from index 1 and take all of the other string characters until the end. Now we could also remove the column because I don't like it. So I'll say dot strip the comma dot strip the comma. All right, like this, comma. Let's run this and see if it removes the comma. I want it to be in the form of an integer so that our machine learning model can learn on it. All right, so since the strip didn't work, I'm just gonna use dot replace, and then here we're just gonna replace the comma with an empty space, and do the same thing here. Dot replace, and then here the comma will be replaced by an empty space. All right, let's try and run it now. All right, so now our web scrapper is complete, and as you can see, it is retrieving features and saves them into a list, and then labels, same thing it does, saves them also into a list. So we can come here into our create model and start working on the machine learning part of this project. So we're just going to say from sklearn import linear model, and then from sklearn dot model selection import train test split. We're also going to say from sklearn import metrics, and finally I think that's it. All right, so here we'll also be inputting x and a y, and we're going to be saying self.x equals x and self.y equals y. So we have our features and labels, and then we can create a function. We'll call it train model. So it takes a self parameter, and we're going to be creating xtrain, comma xtest, comma ytrain, comma ytest. It's going to be equal to train test splits with self dot x, self dot y, and then here our test size is going to be equal to 0.2. What this does is it takes our features and labels and splits them into training and testing. So 20% of our features will be for testing purposes and 80% will be for training purposes, and same goes for our labels. And then after we're done with that, we can say model equals linear model dot linear regression, like this. And then we're going to be saying model model dot fit on X train and Y train, and that will train our model for us. Now let's define print accuracy to get the accuracy of our model. Actually, let's not do that. All right, let's just use the X and the Y. So use all of our data to train it, and let's not care too much about the accuracy here. What's wrong? Okay, it has to be self.x and self.y. All right, so the only thing left is we have to modify some of our data because our data is in the form of a string and we don't really want that. So we'll create a label encoder. So le equals label encoder. Label encoder like this. Let's import it. So it imports it here, and this will allow us to transform our data. So we're going to be saying for I in range, and then we'll take our self.x. So we'll take our features, and we'll take element 0. So let's say this is the first element in our list. We'll take that, and we'll take the length of it. All right. So in this case, the length will be 3 because we have 3 elements inside our list. And what we want to do is say x. So take self.x. So take our entire features array. And then here we're gonna take we're gonna put a column, comma I. So it's gonna loop through the columns, and and it applies it to every single row. So for every single row, it's gonna loop through the columns and it's gonna transform the data. So we're gonna be saying le dot fit transform, and basically inside we want to transform, well, exactly, we want to transform the same thing, right? So that it transformed that particular data into numerical data. So we'll convert it into numerical data, and we don't need to do the same thing for y, simply because our y is already in the form of an integer. All right, so now all what's left to do is say we could print our self.x model equals linear model dot linear regression, like that. And so that should take care of training our model. And then here define predictions. All right, so predict, and here we're going to be saying we're going to asking the user to prompt make a model in a year. So we're going to be saying ma equals input, please input make. All right, and then we're going to be saying the same thing for the model and the year. So mo and yr, please input a model and please input a year. And we're going to be saying inp for input is going to be equal to a list that contains the make, the model, and the year. We're going to be doing hold on here, label encoder. We're going to be saying our input, so the input that we can read, or that our model can read, is going to be equal to le here let's do self.le so we can access it in our other function. Self.le equals, so here's self.le. Here we're going to be saying self.label encoder so that we can access it dot transform and our inputs. So this will transform it and give us an array. And we're simply going to input that into our model. So we're going to be saying predictions equals self dot model. So we need to, same thing here, self dot model and self dot model. So self dot model dot predict, and here we're gonna simply pass in our inputs, and then we'll just print predictions, and the predictions have to be retransformed into readable data. So we're going to be saying inverse transform. So print self.le.inverse transform of predictions, and this should give us the predictions of our model. We just have to go here to our main source file. After we're done with the features, we can create a model. So md equals mdl for model equals create model dot create model. Here we're going to be simply passing in features comma labels, and we're say mdl dot train model. So we train the model, and then mdl dot, and then we can say while true mdl dot prediction, so that it keeps asking us for predictions. All right, now let's I'll let this run for maybe an hour or two, and then come and see how it does. So let me just change the scroll range so that I get more data. Let me put it to, how much should I do? Let me put it to 10. This is just for a small test, and then I'm gonna make bigger tests. I'm gonna let it run for way longer and see how it does. This is just to see. Actually, let's make it 1 just to see if it works. Basically, if the code works, and if it does work, then I'll make it run for way longer. All right, so let me stop this and run it again. This is just to see if it works. It's probably gonna take a couple of minutes. I'll come back whenever it's done. All right, here I just made a mistake. We don't need to do all of this. All we have to do is just print predictions, because predictions should just give us the amount of money. And then apparently I made a typo, predictions. All right, that's it. Just stop it and run it again. Stupid mistakes. All right, so let's make a couple of modifications here, because it's not going to work really well. So here let's take the length -1. So we just take the first 2. Let's transform these 2. All right, and for the last one, what I'm thinking is just converting it to an integer. So basically all we're going to say is self.x. We'll take all of them. For the I and for the j, we'll just take 2, which is this one, the last one. It's going to be equal to int of that. So just convert it to an integer. So all of them, convert them into integers. And here, yeah, that's it. Now here for that, this one is just converted to, so we'll say that. All right, so transform, and then our imp dot append. There's a couple things we need to do. Let's import numpy as np, and then here we'll say here model.fit np.array. So of course we have to convert it to a numpy array, and same thing for the y. But the y, let's make sure it's integers as well, so that the price are not strings but integers. So self dot y, and take all the elements equals int of self dot y and all the elements, like that. And then here we'll say, hold on, we'll fit transform the first two, and then what is our input? Our input, yeah, it should return an array, so we can convert it to a list. So list of our input dot append, and then here we'll just take the integer of the year, like that. And here we'll say we'll convert it to a numpy array, so np dot array. So I hope this makes sense. So we only applied the label encoder on the first two, which are strings. We convert the last one to an integer and then combine them, all of them, into a big list, which we then convert into a numpy array and fetch it into our neural network to predict for. And this is basically the same thing we did here, -1, so that we only convert the first two elements. The last one we just converted to an integer, and same goes for the y, or the labels. So here the features we separate. So with the first two, we use the label encoder to convert them into a numerical value. Since this is already a numerical value, we don't really need to do that for the last element. Hope this makes sense. Now we can run the model. Run the program, I mean. Alright, so I got an error here, which comes to show that I shouldn't just use the try statement on only these two lines. I should use it on everything. So let's just bring it back here, and then well, all of this should be moved by 1, and same goes for this and this, like that. And this is useless. Alright, so this should do it. Okay, this is not aligned properly. Now it is. And there we go. This should fix any potential issue. Let's run this again. Alright, so let's try and solve the new error that came up. So here we're going to be saying we're going to be converting the array into numpy array from the very beginning, like this, and then the same thing here, like that. And then do the same thing here, numpy.array, and convert this into array. But I don't think this is going to fix the issue. So here, let's also print them. So print self dot x, and print self dot y, and then yeah, print. We can print here, print our input, and take a look at it. Alright, so it seems to have worked. Basically converting the list into a numpy array here at the beginning did it. And here, if we take a look at our data, we have Honda, Mazda, Lexus, Honda. And if we take a look at data after it's been encoded, Honda has been converted to a 3. And then, as we can see, it reappears as a 3 down there. So we can know that Honda is a 3 and that this is working properly. All right, so it changed, it converted them into here numbers. So now all what's left to do is convert everything to floats, float data type. So here, when we're trying to do our fit model, we'll say numpy.array dot to hold on, what was it? As type. So as type, and then np dot here we can, I think int should do it, and same thing here, as type np dot int as well. All right, so this should fit our model, and we'll also want to save our model. So we'll say job_lib dot dump, and then here we'll call it model dot sav, and we are dumping our self dot model. And then here's we also need to import from sklearn. All right, there we go. So imported sklearn.externals joblib. So this will save our model, so we don't need to run the web scrapper every time. So this should do it. Let's run it one last time, and we'll see how it goes. All right, since we're converting the types here to integers, these parts are useless, so let's just take them out, and that's what caused the error here. So let's just run it again. Also here, let's go on scrapper.py and create a new function. Call it close window. All right, and all this does is close this Chrome window here. So we're gonna say self.driver.close. Hold on. Close like this, and go back to main, and we'll see. We'll say here we'll create a variable, call it refs equals sc dot get hrefs, and then here we'll use it. We actually I think it's gonna work if we just simply say sc dot close window here. Let's try and run it. All right, so the window is closed. As you can see, it's not there anymore, and we're still sending the request, the HTTPS request. It's still working. All right, perfect. All right, so just a few last things to modify so that all of this works. Here it seems we have an error, so let's convert the new array. So say as type int, just like we did for the other ones. And also what I'd like to do, it's to save the data somewhere, because we needed to create the label encoder. And if, for example, we're gonna save the model here and use it in another program, we need to access the data as well to have the same label encoder. This way, for example, a 1 here would be the same as a 1 in our other program. So we need the same label encoder, and to do that, let's just say numpy dot np dot save. Then here we'll say labels and we'll save self.x, and then np.save, and then here we'll have features. Well, it's the opposite actually. Self.y, and then here features is self.x. All Alright everyone, so let's just fix this prediction function here because it returns an error. So let's remove all of this and let's change it a little bit. So here what we're going to be saying is we're going to be defining x, our x variable is going to be equal to np.load np.load here so we need to save our all right, so we did it here. So here we saved our numpy array into our directory here as labels and features. So what we're going to be doing here in prediction is just we're going to retrieve those arrays back. So we're going to be saying x equals np dot load, and then here it's features, and then the extension is .npy, so npy, and y is going to be equal to np.load, same thing, labels .npy. Make sure that you copy these the exact same way, features and labels. All right, so after we're done with that, this is going to return a numpy array, and then x I think is in 2 dimensions. So what we need to do is do operation on the matrix and do a transpose, and let's save it in a temporary variable called a, do the x dot transpose. And what this does is, if you remember from linear algebra, is that it will invert all the columns and the rows. So for example, if we had a matrix like this, A, B, C, hold on, let me explain it to you down here. Let's say you had the matrix A, B, C, D, E, F, C, D, B, C, D, E, F, G, H, I. All right, so example, imagine this as being our list of features. So we have feature 1, feature 2, feature 3, and then here feature 1, feature 2, feature 3. What we want is we want to group all of these together. This way we can pass it into our label encoder and it will be able to identify common names. For example, if we have Mazda, Toyota, and Mazda, it will know that A and G are the same. So we need to find a way to group these together, and we do a transpose for that. Now let's create our label encoder. LE equals pre-processing. Hold on, I think I need to import it. Label encoder. So LE equals label encoder, like that. And we will then, all right, so what we're going to be doing is first we're going to be fitting our label encoder on the first row, so A0, and then our make is going to be equal to LE dot transform, and then here we pass in a list with MA. So what this does is it takes our MA and it will transform it according to our label encoder, which we already fit on our data. So it will know, for example, if let's say Toyota is represented by 1 and we type in Toyota, then MA is simply going to be equal to 1. All right, now let's do the same thing for the second parameter, which is the model. So we're going to be saying LE dot fit A1, and then MO, which is the model, is equal to LE dot transform, and then here we type in MO. All right, that's it. Now our input is going to be equal to a list. First element will be MA0. This is simply because LED transform returns a list, but the list only contains one element, so let's just take it, MA0, MO0 for second input, and the third input will be a conversion, so we'll cast our input 2020. It's going to convert it from a string to an integer. And now all we have to do is say predictions. Hold on. Here we're dumping the model into model.sav. So we have two options. We could either open the model, and I think that's what we're going to be doing. So model equal, instead of using self.model, it's going to be equal to joblib.load. Here we're going to be loading model.sav, and then all what's left to do is create our predictions. Predictions is going to be simply equal to 0 dot and it's a list, so now is print our predictions. This is what's gonna do the predictions for us, and it seems like we don't even need the y. Yep. So here the y is useless. We don't need to load it. And another way you could do this, instead of saving it and retrieving it, is creating a new variable here. For example, self dot a equals self dot x, and then self dot b equals self dot y. And now self dot x is going to be modified somewhere here, but self dot a is not, because we saved it before we were doing modifications. So here, instead of x, we could have used self dot a. That would have also worked. So instead of x equals np dot load, we're just going to be saying x equals self dot a, and it would have resulted in the same thing. And here, the model, we could either do this, or we could say model equals self dot model. So if this doesn't work, you could do this. Now, after the program runs, it saves features, labels, and a model. You could take those and copy them in a new Python directory. For example, here, you will paste them and copy this function, exactly the same code, paste it here, and now you will have a program that will do predictions on your data without having to train the model again, because you already saved it. So for example, if you run this, this is just the function that we called predict. It's exactly the same code. So if we input a make, we can say Toyota, and then for a model, Camry 2000, and we get a negative value because we didn't train our model with enough data. But it's hilarious to think that the car has no value at all, so much so that if you want to get rid of it, you need to pay. Anyway, let's take hold on, let's take a BMW and 3 Series, and then let's say 2015, and it gives us a value of about 20k. So as you can see, this is trained on very little data. you should, and then run this, you will have pretty good accurate values. So the model will predict, will give you a good estimate of what's the value of that car, giving the model, the make, and the year. And if you find a deal that's lower than this, that means you're doing a good deal. And something that's more expensive than this, that means you're probably getting scammed. That means it's probably a ripoff. So that's it for this tutorial. I hope you guys enjoyed and learned from this web scraper and machine learning combination that we just did. And if you don't know Python, once again, you can always find us at our website, thedlacademy.com. Hold on, let me just load it for you. All right, so this is thedlacademy.com, where you can learn machine learning, programming, and algorithms. So you can find our Python course. We also have a machine learning course, absolutely free. So go check it out. I hope you guys enjoyed this video, and we will see you in the next one.